The 12% annual? What do you think? The monthly? So let's think about it. How did we build these equations? Yeah. Yeah, and you can absolutely do that. You can adjust this so that our principal is not a big number. If you want to put this as our amount in our account is our principal, which was our 20K, you can do it as 20 or you can do it as 20,000. Either way is totally fine. Just remember that when we're looking at our answers here. We're going to do 1 plus, what is our rate for our annual one? 0.12, because we got to put it in as a decimal. I want that to be matching. So that's coming from this rate. And then the piece we're putting in as an exponent, we're putting in our years up here. I'm going to have that be a y so we know it's years. How would we write a very similar equation for our monthly interest? So we'd have our A equals our same starting amount. It's our same principal. But what's different for our rate? 0.01. That happens. That's the reason we go through it and why it's not like a test. So our 0.01. And this time we're going to put as our unit of time months. So you can either do it just like that and think it each time, or if we want to put in years just to make things match up, how many months are in a year? 12. So I could do 12 times however many years it's going to be. That way I can compare the same thing. You don't have to do that. If you want to type in months, totally valid. So looking at these, we want to see which one would be better. So think about how much money we would owe after the 1 year, 2 year, 5 years, 10 years. For each of these. Let's find out. After 1 year on our annual loan, if we paid it all off after the 1 year, how much would we pay off? Yeah, our 22,400. So it showed up in our calculators 22.4, 22.4K would be a way to write it, or you can put 22,400 because we just kind of cut off the 3 zeros. How much would we pay off if we did that same amount of time on the monthly interest? The 22.537K. So even at this point, we can see which one's going to cost us more. What do we get for 2 years on both of these? Yeah, you both jotting out good numbers on me. I could hear you both. You're doing great. So our annual count, we have our 25,088.088K. You can do it like that, or you can say, well, that's $25,088 because we have enough decimal places now we can see it. Either way is totally fine. And our 2 years, we can see, was our $25,395. Well, I guess I've switched my head into writing that as dollars now because I wrote that one definitely as dollars. I'm going to switch that back so that we're doing the same units, just so we can keep things consistent. So, okay. So already in just 2 years, if I pick the monthly interest, I owe $300 extra. My little PSA on please don't do this. If you wait 10 years to pay off your car loan, how much money do you owe for this $20,000 car? We're going to do it on both. On our annual one. Yeah, and change. $62,000 on your $20,000 car. You've paid more than 3 times what your car is worth. Do not wait 10 years to pay off your car loan. Even in our monthly loan with our worst interest rate, it's even more than that because it's going to be about $66,000. Do not wait to pay off your car loan for 10 years. That is a terrible financial decision. Perchance. You definitely do not put a house on your credit card. So when you're doing things like this and you're trying to do repeated calculations where you're just changing one little thing, there is a way to actually do that shortcut in the calculator. I'm going to show you how to do that because this is one of those cool things that the yellow calculators do really well. If we wanted to do our annual interest, I could hit this table button and it says enter function. I could put in my 20K times my 1 plus, that one was the 12, 0.12. We wanted it to the power of this variable button. We've never used it before in our entire lives in there. Boop. And if I hit enter, it's going to start at 0. It'll jump once, and it will automatically calculate.
Where was this like a few years ago?
Right there.
Nah, I mean like
It was
what
right
were the
there.
teachers telling us, man?
It's the super secret mode. So you can have the calculator help you with your repeated calculation. It's in table is where you can get that. So I could even come in here and change this to do my 0.1 to get that thing. And I could even do the 12x. I can do my monthly here. I can pick where I want it to start. I could have it in half steps if I want to. I can pick whatever the heck I want. And it'll do our calculations for us. It's the button that says table, and then the letter is right here next to the 4. It'll spit it out for you. So that's one of those things that's very, very handy about the yellow calculators that we don't use all that often because it's really only used if I need to do over and over and over again the same equation. So this is one of those really handy if we're trying to make like a table for graphing, or if I need to do repeated pieces of that same, how many times does it pay off? So that's one of those things just like to kind of tuck in your pocket when you go to other math classes. We love that. So one last bit I want to talk about before we have one last thing. As you guys have a lot of space on that page where if you want to write things down like this, you can. I just wanted to quickly talk through the different kinds of interest we're going to see this chapter. Just because we've started to see some and we've never really clarified what our pieces are. So I want to make sure we do so. The one that we see rarest of all is called simple interest. And this is really for things like certificates of deposit, which is a kind of investment that's done in the banker does the calculation for you for the most part. But all it is it's a linear function. Simple interest is not used super frequently, but if I had 10% interest of my $2,000, I would find my 10% of 2,000, so $200 would be what I'd earning in interest, and I get $200 each month. It doesn't change. The amount of interest does not change. So it's a linear function. Simple interest is not super common. It is linear. What we have over here is not linear. The amount that's changing changes. And the reason that happens is because on the annual one that we had, we were earning interest on our interest, but only once every year. On our monthly, we were earning interest on our interest every single time. So when I had more money due in February than in January, I was then going to pay interest on that much due too. And then in March, I was paying on the February interest. And on April, I was paying on January and February and March. So it's paying on the interest as well. So simple interest does not do that. It's a linear function. Our compound interest is what we've been working with. We've been mostly using this one for our annual. And our other kinds of compound interest, like if we had an annual rate with a monthly compounding or quarterly compounding, you've seen this one before. It's a mess, but it's a thing. And the only time we have anything other than that would be if we have continuously compounded. We're not going to use that super frequently simply because it is more like an investment style, or you can make the argument for population growth kind of stuff. Most of what we're going to do is going to use this. Ooh, careful. All good. Just make sure we're all awake. I've been known to do that every now and then. I won't point through a book to the floor to make it clap and make a big noise. Okay, so we're mostly going to use this guy, but this one is possible. We're mostly going to get to that one, I think end of next week we'll get to that one when we get to page 120. This one I think just did in when we were looking at the chemistry ones. We saw this a little bit in the chemistry ones, but we're not going to do tons with it with money. So I wanted to go through these just because they hadn't mentioned them yet, but I wanted us to see them. So our simple interest is linear. It's not going to be a thing we see super frequently, but we will see it every now and then. Compound interest, we mostly use this guy, but this one's possible. And only if it's continuous, if it says continuous, it has to say the word continuous, do we use the one with E. So these are some good formulas to have and or know and all that jazz. Because our last thing for us to do today is our very, very last I Pick Your Partners quiz. Remember those things, like card activities or I Pick Your Partners? It's the very last one. So we're going to do that. We will have our card activity, I think it's next week, end of next week, or beginning of the week after. And that'll be the very last card activity. What? We're approaching the end. Oh my gosh. The very last time we get to do the little quiz where I pick your partners and you hate it so much. Oh my gosh. The very last time we do the card thing, we have to do more cards. No, oh my gosh, I have to do more cards. Oh my gosh.
She made it worse. That's the truth.
Okay, so we're going to do the I Pick Your Partners quiz. Okay, remember, I don't grade them for correctness. I grade them for how you think. So show me how you're thinking. Show me what you're thinking. If you do no work, you will get assigned to a partner who also does no work. And it won't be the person you sit next to. And you will then not be assigned to a partner who you sit next to. If you do the work and you happen to match up with your neighbor, that's a totally different thing. If you do no work, you will not get back with the person next to you. This is the very last one where y'all don't get to take your own part. Alright, so do this. This is the very last thing of the day. No, this is the I Pick Your Partners day.
You're welcome.
The last one.
This is a whole new topic.
Alright, remember I don't put them in for PS4.
Yeah.
Remember our simple interest is our linear.
It wasn't your lights in the
Our compound interest is not linear. Compound is like the one we just did.
Let's get this table out.
Alright, so the compound interest is like the one we just did. This is not a work together page.